Hello everyone and welcome back. So in this video we are going to learn how to create our RTC client. I'll go to my WebRTC package and create my RTC client. It's going to inject or being injectable, and as arguments we're going to pass our application as the context. So here we'll have our init function, which is going to get a username of type string and a peer connection observer of type peer connection dot observer, and we will use them as our global variables. So let me create latent var of username and my observer of type peer connection. So first thing to do is to create a function called init peer connection factory, and it's going to need a context. So let's create this function, and inside it we are going to use peer connection factory and initialize. But inside here we're going to need an option. So let me create my options. It's going to be peer connection factory dot initialize options. Use the builder class and pass context to it and add the extra option. So the first one is going to be set enable internal tracer to true, and then set field trials to WebRTC -h 264 high profile / enable / and then call the create initialize options. So we have our options now, and then we'll pass it to our initializer of peer connection factory class. So after initializing the peer connection factory, we now want to create our peer connection object. So first let's create a global variable of peer connection object, peer connection, and it's going to be null. But inside here, after we initialize our factory, we're going to initialize our peer connection. So I'll make a function called build peer connection and pass my observer to it. Observer. So let's create this function. But to create a peer connection object, first we need to create an instance of peer connection factory. To do that, I'll write a function that is called build peer connection factory, and it's going to return the peer connection factory. Remember, it's different from init, the peer connection factory. So we'll return the peer connection factory dot builder and set some property here. So set video decoder factory to default video decoder factory, and as the context, which is going to require an EGL based context. So I'll create one here, private val root EGL base is going to be EGL base dot create, and we give it here, and set encoder video encoder factory to also default video encoder factory, and as the context we'll give it the base context, and for enable Intel VP8 encoder will pass through, and H226 high profile will also pass through to it. So the next thing is going to be the option. So I'll set some peer connection factory dot options and apply some properties to it. So disable encryption to false and disable network monitor also to false. And after that we'll create peer connection factory. Sorry, I also have to use the base context here, so we're good to go now. So to use this peer connection factory, I'll create an object using lazy. So private val peer connection factory is going to be, or by lazy build peer connection factory. So right here, using our peer connection factory, I want to create my peer connection. We are going to need two arguments. The first one is going to be my iServer and the next one is going to be observer. Let's create my iServer object here. It's going to private val of iServer. It's going to be list of a peer connection that iServer. So I'll pass one here. Don't forget to use the TCP turn servers because in some cellulars mobile data the UDP packets are blocked, so you won't get any ICE candidates to start the conversation. So your return server has to accept the TCP packets. Okay, so right now we have created our peer connection. After creating my peer connection, I'll create two functions. One of them is init surface view. It's going to get a surface view renderer, and using run block we are going to prepare our surface view renderer to use it. So first we need to use it as a global variable again. So let me create a global variable of view renderer private val var. I'm gonna call it service view renderer. So here service view renderer is going to be this view or this, and after that I'm going to set mirror to true and set enabled hardware scalar to also true, and then using init method and EGL base context and pass the null as the render event, we prepare our surface view renderer using these functions. And after that I'll have a function start local video capture. So this function is going to prepare my media streams and other stuff to start a conversation or a video call or an audio call. Is going to also have a surface view renderer. So what we are going to get from this function is going to a local stream private var of local stream of type media stream. It's going to be null, and local audio track of type audio track from WebRTC library. It's going to be null as well, and a local video track of type video track from WebRTC also, and it's going to be null as well. But we're going to need two IDs for our local tracks: private val local track ID is going to be local track, and local stream ID is going to be local stream. So right here, first thing, I have to create a surface texture helper. Surface texture helper is going to be surface texture helper that create. The first argument is the thread name, so I'll use the current thread name, and the next one is EGL context, so I'll pass the EGL base context to it. And the next thing, we are going to need a video capturer object, but we don't have it. So to create a video capturer, I'll create a function called get video capturer, and it's going to get the context. And it will return video capturer from WebRTC library. So it's going to be camera 2 enumerator, get the context and run some code inside its block. But first we need to save a reference from our camera 2 enumerator. So let me camera 2 enumerator is going to be a type of camera 2 enumerator, and it's going to be null as well. So here camera enumerator is going to be this object. So here I'll use my video capture function and pass the context to it and initialize it, and we'll pass the surface texture helper, and as the context we can use the local video context or the context from our class, doesn't matter, and local video source, which I don't have here, observer. So we have to create our local video source as well. So right here I'll create my video source, local video source. I'm going to use lazy and use peer connection factory, create video source, and pass false to a screencast. And let me create my local audio source as well by create audio source, and as the constraint I'll just create a new object of media constraints. So let's go back here. After initializing our capturer, then we start capturing like this. This is going to be our dimensions, 720 and 480 for the dimension, and 20 as the frame per second. So right after that we'll create our audio track and video tracks. So I'll initialize my audio track like this using peer connection factory, create audio track, and as the ID I'm going to pass my local track ID and concat it with an audio at the end, and as the audio source I'll just pass the local audio source. So here's my audio track, and for local video track I'll use also peer connection factory to create video track, and as the ID again I'll local track and use the video string to concat with it and pass the video source, so local video source, and then we're going to create our local stream and make it ready to pass to our peer connection. So using peer connection factory again, thanks to that, we'll create our local media stream, and for the label I'll use the local stream ID and add my audio and video tracks to it. So the audio track and local video track. So after creating our local stream, we'll add it to our peer connection. Add stream and pass the local stream to it. Okay, so now our peer connection is ready to create calls. So that's it for this video. It is already too long. We will continue our RTC clients on the next video. Till the next one, see ya.